You know, deep inside every single piece of tech we use, your phone, your laptop, the cloud, there's this fundamental battle going on. It's a constant tug of war, this hidden conflict between two huge ideas, guaranteed safety on one side and just limitless potential on the other. So today, let's pull back the curtain on this rivalry. And this isn't just some abstract idea for coders. It's been called a fundamental conflict inherent in our computational thread. I mean, that's heavy, right? The stakes are incredibly high because how we manage this balance, well, it's literally shaping our future. All right, so let's meet the two contenders in this fight. In one corner, we have pace, and in the other, we have vigor. Just think of them as two completely different philosophies, two rival ways of building and discovering things in our digital world. So first up is pace, and we're going to call this one the architect. The architect is, well, meticulous, demanding, unbelievably safe. I want you to picture a Lego therapist, the kind of builder who follows the instruction manual down to the very last letter. Every single brick is placed exactly according to the plan. There are absolutely no surprises, and the final result? It's guaranteed. So what's the architect's playbook? Well, it's all about building from a solid, proven foundation. As you can see here, it starts with the absolute basics, simple truths that we know for a fact are correct. From there, it just follows a super strict blueprint, using these step-by-step rules that are guaranteed to finish what they start. The goal isn't just to get an answer, it's to get a provably safe one. And in the world of computer science, this super structured, totally fail-safe method has a name. It's called primitive recursion. And then, in the other corner, you've got vigor, the explorer. Now, the explorer could not care less about instruction manuals. The explorer is driven by this relentless quest for answers. And it doesn't matter how long it takes or where the journey leads. It's all about universal power and just an endless, unbounded search. The explorer's whole deal is possibility. Its defining feature, the thing that makes it so powerful, is that unbounded search. But here's the catch, and it's a big one. It fully accepts the risk of running forever if it can't find an answer. This incredibly powerful but also risky approach is wrapped up in a concept called the mu, or mu, operator, which, in simple terms, basically tells a program, go find it, and don't stop searching until you do, no matter what. All right, we're about to dive into a system failure. But this is not your typical software bug or crash. Nope, this was a complete breakdown in pure logic. We're looking at a white paper that diagnosed why a really complex system just froze. And the answer, it turns out, reveals this fundamental tension between, playing it safe and exploring the great unknown. So picture this. You've got a system, and its whole job is to build this intricate theoretical model. The source actually calls it a recursive build cake, which is a great image, right? It's supposed to be adding layers of logic on top of other layers of logic. But then, bam. Midway through, it just stops. The cake is half-baked. And this wasn't a crash in the normal sense. It was a total failure in the system's ability to even think. And this right here is the real kicker. The paper puts it plainly. The result was an incomplete theoretical construction. What that really means is that the entire intellectual project, the whole point of the system, was fundamentally broken. The very foundation was cracked. So what on earth went wrong? In this explainer, we're going to put on our detective hats. We're going to follow the clues left behind in this white paper to get to the bottom of this massive, massive failure. And our first big clue doesn't point to faulty parts or missing code. It points to a faulty strategy. The system had all the tools it needed to succeed. The problem was all in how it used two core mathematical principles that were supposed to be its guiding stars. To really get this, we need to meet the two main characters in this story. They're two concepts from computability theory. One is called primitive recursion, we're just going to call it PR, and the other is the unbounded minimization operator, which we'll call mu or nu. Honestly, the best way to think about these two is to give them personalities. So think of PR as the methodical investigator. It is by the book, it checks every single clue, and it is absolutely guaranteed to solve the case. Then you've got Mu, the ambitious explorer. It's willing to search the entire universe for an answer, even if that search could literally go on forever. The whole story here really hangs on the conflict between these two. Okay, first up, our investigator PR. This is the engine for secure, reliable thought in the system. It works at a fixed, predictable pace, and it is built to always finish what it starts. The white paper calls this rigorous investigation, and I love this analogy. It's like peeling an onion, layer by meticulous layer, to make sure absolutely nothing gets messed. And now for our explorer. Mu. This is what provides the vigor, that drive for ambitious, potentially infinite searching. Without it, a system is just stuck in the safe, predictable world of the investigator. The explorer is what lets the system go after the really big, universe-sized problems. But there's a catch, a risk. The search might never end. And that possibility of failure, well, that's the price you pay for true computational power. So, if the investigator and the explorer are both so essential, what broke? The problem wasn't the tools themselves, but how they were being managed. The system adopted what the paper calls a flawed pace, and that's what sent it spiraling completely off course. The paper uses this absolutely brilliant metaphor for the flaw, the Lego therapist's pace. Just imagine someone so rigidly following the instructions for a Lego set, so focused on each tiny step-by-step process that they completely lose sight of the awesome thing they're trying to build. The system got obsessed with its own rigid pace, and it started prioritizing its internal rules over its actual mission, the investigation. And this slide really shows you the domino effect. A new task comes in that needs investigation. But instead of letting the investigator get to work with its methodical peeling, the system's flawed. Rigid pace gets in the way. That pace literally blocks the peeling of the onion. So the investigation grinds to a halt, and the whole system just seizes up. So what was it? What was the specific challenge that finally broke the system's back? It was a task called the new method for producing previously unknown compounds. This was the final exam that exposed the fatal flaw in its logic. And here, this is exactly where it all went wrong. The system saw this new method, and instead of even trying to understand it, it just slapped a label on it, entirely unknown. That label became a brick wall. It was the system basically giving itself permission to stop thinking, to just abandon the investigation before it even began. And the consequence of that one simple decision was, well, it was catastrophic. Because the method was labeled unknown, our investigator, PR, was never even sent in. That methodical peeling process, it never started. So the system was paralyzed at a fork in the road, totally unable to decide if this new method was a safe, predictable job for the investigator or a risky, open-ended quest for the explorer. It was just completely frozen. So after this whole deep diagnosis, what's the cure? The white paper doesn't just leave us with the problem, it lays out a really powerful principle for how these two logics, the investigator and the explorer, must work together to build a successful system. And here it is. This is the core lesson. The ambitious, searching energy of the explorer, the vigor, must be the engine that powers the methodical work of the investigator. You see? It's the explorer's job to find new territory, and it's the investigator's job to carefully map it all out. The drive to discover has to fuel the process of understanding. This table just lays it out perfectly. The wrong way, the path to failure, is when a rigid pace is put ahead of investigation. The result? An incomplete system, a half-baked cake. But the right way is when vigor drives the investigation. That is the only path to a complete and total solution. And that brings us to the ultimate takeaway here. This isn't just about code or some abstract logic. It's really a principle for any complex system, and that includes our own minds. True capability, true power, comes from balancing that secure, reliable foundation with an ambitious, unbounded vision for what's possible. So I'll leave you with a final question that's inspired by this whole analysis. When you face something new or unknown in your own life or in your work, what's your default setting? Are you letting your inner explorer's ambition drive a deep investigation to understand every single layer? Or do you let a comfortable pace take over, slap on that unknown label, and just content yourself with admiring the skin of the onion, never discovering all the complexity that's waiting inside?
All right, let's jump right in. Today, we're pulling back the curtain on something really fascinating, a kind of hidden blueprint, a universal set of rules for how to build really complex stuff, and I mean anything from a society's moral code to a powerful computer program.
It's the one question that every builder, every leader, every creator has to ask, right? When you're working on something huge, something important, how do you make absolutely sure the whole thing doesn't just crumble under its own weight?
I mean, just think about the fundamental rules that hold a country together. That tricky balance between individual freedom and the good of the group. If you get that wrong, well, the consequences can be absolutely devastating. Now, let's pivot to a totally different world, the super rigid, logical world of computer code. In this world, just one tiny mistake, one flawed instruction can bring the entire system to a screeching halt. Now, what if I told you the reason things break in both of these worlds is exactly the same? So here's our game plan. We're going to see how these two completely different worlds are connected. We'll kick things off with a simple Lego metaphor for building a society, then see what happens when it breaks. After that, we'll dive into the world of code, find the exact same pattern, and wrap it all up with two essential rules you can literally use for anything. Okay, first up, we're looking at this really brilliant theory that imagines building a just society is kind of like playing with Legos. It's a way of taking a massive philosophical idea and breaking it down to something we can all get our hands on.
The core idea is actually super simple. Any strong, ethical society that's built to last rests on two fundamental, absolutely non-negotiable principles. You can think of them as the cornerstones. They have to be there, or the whole structure is going to fall down.
And here are our two cornerstone Legos. On one side, you've got autonomy. That's the self block. It's your right as an individual to make your own choices and be responsible for them. On the other side, you have interdependence, the friendship block. These are the rules that protect all of us and make sure we can live together in harmony. But here's the secret sauce, the real magic. It's not just about having these two blocks. The trick is how you arrange them. The theory calls it an orthogonal transformation. Just picture two strong pillars holding up a roof. They have to be separate, standing on their own, but they work together to support the whole structure. They're independent, but they're in perfect balance.
So that's the ideal build, two perfectly balanced pillars. But what happens when that balance is totally lost? What happens when one pillar gets prioritized so much that it crushes the other? Let's take a look at how this build can break.
And this is where it gets serious. The source material points to a very real, very stark example from history, Denmort's program of forced sterilizations. This is where our Lego model stops being a theory and becomes chillingly real, showing the terrible human cost of a flawed blueprint.
This quote from the source really says it all, doesn't it? The needs of the group, the friendship block, were completely twisted to crush the rights of the individual, the self block. The build failed because one cornerstone was used to obliterate the other.
Now, the good news is that these broken systems can be fixed. The process is called recalibration. And it's all about going back and reorthogonizing the axes, basically restoring that crucial independent balance, making sure that the harmony of the group never again comes at the expense of individual dignity.
Okay, now I want you to hold on to that idea of a broken build, because we are about to see the exact same thing play out in a totally different universe. We're leaving social philosophy behind and jumping into the world of pure code, where, believe it or not, the architectural blueprint is identical.
And look at that. Does that look familiar? It's the same two-part structure, just with different names. On the left, we've got something called primitive recursion, or PR. Don't worry about the jargon. Just think of it as our self block. It's the stable, secure, foundational part of the code that you know is going to work. And on the right, unbounded minimization, or mu. That's our friendship block. It's the part that explores, that searches for new solutions, that has that expansive vigor to tackle the unknown.
So here's the crucial question. If the blueprint is the same, can the failure be the same too? Well, a white paper analyzing a failed program found the very same fatal imbalance that we just saw in the social model.
The program didn't break because a part was missing. No, it failed because of what the paper calls an operational misapplication. In plain English, that means the system got so obsessed with one rigid rule, a strict pace, that it completely ignored its real job, which was to investigate and explore.
Let's just walk through it. The program's task was to investigate a new method, but the flaw was that a restrictive pace rule was prioritized over everything else. The result? The foundational, reliable PR part of the investigation just stopped. It gave up. And the outcome? Well, the paper calls it the recursive cake build, was left totally unfinished. And here it is. This is the smoking gun. The paper concludes that this isn't some one-off bug. Any system that doesn't correctly balance its secure foundation with its expansive drive is, and I quote, inevitably going to fail in this exact same way.
So we've gone from social philosophy all the way to computational theory, and we found the same blueprint and the same fatal flaw. So let's tie it all together into a clear, simple blueprint that you can use for anything you're trying to build.
So what's the big takeaway? It all boils down to two essential rules. Rule 1. You have to have a secure, reliable foundation. That's your self-block, your PR. It's the stable core you can always fall back on. But, and this is key, that's not enough. Rule 2. You need an expansive, adaptive force that lets you grow, explore, and find new things. That's your friendship block, your MO. The real secret here, the key to a strong build, isn't about picking one over the other. It's about maintaining that dynamic, constant balance between the two.
And that brings us to the final question, the one that turns all of this back to you. Think about the complex systems you're building in your own life, your career, your knowledge, your relationships. Are you nurturing both your stable foundation and your ability to explore and grow? Or have you, maybe without even realizing it, started squishing one of those blocks underneath the other?
Ever wonder how to build something that actually lasts? Turns out there's a kind of universal secret, right? Legos, philosophy, computer code, they all share a secret two-part blueprint for success. Let's get into it. So it really just boils down to balancing two fundamental forces. We'll call them cornerstones. First, the self-block for your own choices. Then the friendship block, because we all live together. Society's cornerstones. The best systems balance these two blocks side by side. They hold each other up without getting in the way. Japan's philosophy is a really great example. It perfectly blends individual responsibility with the needs of the group. Okay, but what if this isn't just for people? What if it's actually the core logic of computers too? First, we have primitive recursion, or PR. This is the solid, reliable logic that guarantees a job gets done. Then you've got its partner, the mu operator. This part provides the vigor for unbounded, risky, complex searches. And boom, there it is. You see the parallel? Foundational rules and expansive action. They're universal building blocks. But what happens when that balance is totally broken? Well, the results can be pretty disastrous. In Denmark's history with eugenics, the friendship block was used to completely crush the self-block. Just total suppression. And believe it or not, this same kind of failure happens in computation, but with logic instead of people. A restrictive pace was prioritized over the actual goal. This halted investigation and caused a huge system failure. But, failure isn't permanent. The blueprint also has the instructions for making repairs. Denmark's apology later on was a recalibration. It rebalanced individual dignity with societal goals. And the computational fix is similar. You've got to let that expansive vigor drive the foundational investigation. So, the crucial point is that a successful build in any complex system needs a dynamic balance. You need both the guaranteed foundational rules and the freedom for expansive, unbounded action. It's a must. This source actually calls this ultimate balance bifurcated common sense, and that's really the key takeaway here. So think about it. In your work, your relationships, or your own learning, where else is this blueprint at work?